Hi guys, you're most welcome to your Sunspot. Today I'm going to show you how to draw shapes of molecules, stroke ions. To come up with the shape of a molecule, what you need to know it is what you call the valence shell electron pair repulsion theory, which tries to talk about how the electron pairs around the central atom repel each other to take up a position that is far apart from each other. So in case we are to come up with maybe a certain molecule, there are some things you are supposed to be knowing. There's what we call the central atom. Then we shall have what we call the ligands. Now the central atom, for example, if I'm to sketch maybe carbon, let me sketch methane. Now in this case methane, that is, in methane we have carbon and hydrogen. So carbon, it is the one that is referred to as the central atom, and the ligand is the one that is referred as to and hydrogen is referred to as the ligands. So in case we are to have the compound that is a complex, that is tetraamine copper 2 ions, this compound or this complex, we are having copper as the central atom, meaning it's the one that can accommodate the lone pairs that are donated by the ligands. So the ligand strictly is supposed to donate, in case it's a complex, donates lone pairs to the central atom. So the central atom should have vacant d orbitals where it can accommodate the lone pairs from the ligands. Now there is also another thing which you need to know. There's what you call lone pair. Now a lone pair, we in case we are to have oxygen, which oxygen is having atomic number 8, meaning it's having atomic number 8, that is, its configuration is going to be 1s2, 2s2, 2p, having 2p4. Being with 2p4, it means these two are the outermost electrons, or simply by saying 2, that is 2 to 6, meaning it is in group 6. But we know that the valence of oxygen, or the combining power of oxygen, its valence is 2. Meaning, out of the 6 outermost electrons, that is 6 minus 2 equaling to 4, there are some 4 electrons that do not take part in bonding. And these electrons that do not take part in bonding, these are what you call the lone pairs. So since there are 4, 2 are going to make what we call a lone pair, in case they don't take part in bonding, because we know that oxygen uses only 2 electrons out of the 6, meaning the remaining 4, those are what we call the lone pairs. So in case we have to sketch how to come up with shapes of molecules, you need to understand the central atom, ligands, and lone pairs. Now what you need to know most is to identify what is the lone pair within a compound or within a molecule or ion you are dealing with. Now for example, let me start with the simplest, that is the shape of water. If I'm to sketch water, so we can see that the central atom, we are having oxygen. This oxygen is the central atom, hydrogen is the ligand. Now oxygen, what you need to do is to investigate the group. You can investigate the group of oxygen, which is group 6. If it is group 6, then it means it has 6 electrons in the outermost. We're having 6 electrons, 1, 2, 3, 4, 5, and 6. Now we're having those 6 electrons, and the ligand, that is hydrogen, we know that hydrogen is having valence 1. Being with valence 1, it means hydrogen and oxygen, they constitute what we call a bond a bond pair. Now in this bond pair, this is what we call covalent bonding. We know that hydrogen should bring one electron and oxygen should bring one electron. Hydrogen will bond with the first electron and the second electron like that. And these four outermost electrons, they are going to constitute two lone pairs of electrons. Now, to come up with a shape, don't forget what I talked about, the valence share electron repulsion theory, which also brings more details that in case we are to have a bond pair and lone pairs, so lone pairs over-repel themselves compared to the bond pairs. Now, to come up with a shape, I'm going to have oxygen in the center. After having oxygen in the center, since I have two lone pairs, one lone pair is going to repel the other at almost 180 degrees apart. Now the bond pairs, we're having two bond pairs, so one is going to be sketched there and another one will be sketched here. That is the shape of water. So we are having two lone pairs, then we have two bond pairs, and this shape is called V. It's called V shape, or what we call bent. If you don't call it V shape, we can call it bent. Okay, now let's try to have another molecule we are going to sketch. In case I'm having boron fluoride. Now boron fluoride, we know boron is found in group 3, meaning it's having 3 electrons outermost like that, and we know the ligand in this case is going to be called fluorine, and fluorine being a group 7 or the halogen, it means its valence is 1. One fluorine will bond with that, then with that, so it means we don't have any lone pair. And since we talked about that, we should have a shape of the molecule that is going to minimize repulsion. So it means we have 3 bond pairs and they are supposed to distribute themselves around boron so as to minimize repulsion. And in case that to minimize repulsion, it means they are going to distribute themselves in a trigonal planar way so as to minimize repulsion. So this is the shape of boron fluoride. Since we have 3 bond pairs and without any lone pair, they're supposed to be at 120 degrees, 120 degrees, 120 degrees to minimize repulsion. This is called trigonal planar, like that. So that is called trigonal planar. Now let's have also another one. Let's sketch the shape of methane. Yes, carbon is in group 4, or the metalloids. Group 4 meaning they're having 4 electrons outermost, like that. Then hydrogen being in group 1 or group 7, valence 1, to bond with that, since there are 4, another one like that, like that, like that. So we don't have any lone pair in methane, meaning our central atom, that is carbon, we shall have 4 bond pairs, that is hydrogen, distributing itself around carbon in a tetrahedral way to minimize repulsion. And this is how we sketch tetrahedral. This is tetrahedral. So this is tetrahedral. So it means all compounds of group 4. Let me say it can be tin chloride, tin tetrachloride. It can be lead tetrachloride. It can as well be, that is carbon tetrachloride, among others. All of them, they are going to have the same shape. Sulfur is in group 6. Being in group 6, it means it has 6 electrons outermost. Let's sketch the 6 electrons. Now the 6 electrons, remember oxygen this oxygen, you see, is having valence. To obtain octet or to obtain noble gas configuration, it's supposed to use its valence too, meaning one oxygen will use those two. Yes, this one will use these 2 electrons, and that one will also use those ones. It's trigonal planar shape. Yes, like that. This is also called trigonal planar. Now let's sketch one for group 7. Yes, let's have it in ionic form. Now what you can see here, it means we have 4 oxygens, but one didn't use its valence. It used only 1 electron, meaning chlorine being in group 7, that is 1, 2, 3, 4, 5, 6, 7. It means the 3 oxygens within out of the 4 used valence 2, meaning they will take that, and the remaining oxygen used only 1. That's why it is having a charge that is -1. So it means, to sketch this, I'll have my chlorine being the central atom, then so this is going to show what you call tetrahedral shape. This is called tetrahedral. So don't worry, it can show resonance. That is, this oxygen, it can be anywhere you want. This is called tetrahedral shape. Ammonia, that is NH3. Nitrogen is a central atom, of course. So central atom, group 5, meaning it has 5 electrons outermost. Being with 5, we have hydrogen bonding with 1, that is taken, that one and that one. So we shall have these ones remaining to form 1 lone pair. And since we said we want to minimize repulsion, it means the lone pair, it will be found on top, where it will repel the 3 bond pairs in a trigonal pyramidal way, so as to minimize repulsion. So this is called, it's called trigonal pyramidal, like that. So feel free to subscribe to Real Science Power for more videos.